Awesome. Let's go ahead and jump into our lesson then. So as a summary of yesterday's lesson, there's technically 3 ways to solve systems of equations, but graphing is not super useful because you can't see where the fraction numbers are on a graph. So the 2 methods I recommend using are substitution and elimination. And if you want to check your answer to see if it's reasonable, you can always graph it and see if the intersection is reasonable for the problem. So as a review, substitution is where you get a variable by itself and then you substitute what it's equal to in for the other variable. Elimination is the one where you add the equations together to eliminate one of the variables. And sometimes you have to multiply by something, like you'd have to multiply by -2 to be able to eliminate the x's or the y's. Yep. It's also called the addition method, I guess, because you add the equations together, but I'd never heard it called that until I read this textbook. So it's more commonly called elimination, I think. Yep. And you can always use either method. They'll both give you the same answer. So you if you're like, I just love substitution, I always want to use it, you could do that. It's just that sometimes it's harder when you're like trying to substitute something like this. So you can just use whatever method you like the most, and different equations usually tend to be easier with various methods. So what we're doing today is we're solving word problems involving systems of equations. So this strategy that I've outlined here is a strategy that you should use whenever you have a word problem. So today's word problems are specifically going to be systems problems where we'll end up with 2 equations and then we'll solve them. But this is a good strategy, even if like on a later lesson or things like that, you're using word problems to solve other types of math problems. So the strategy is you read through the word problem and you identify the stuff you know and the stuff you need. And then after you know what you need, you're going to define variables for those things you need. So you'll say like, oh, I need to know how many people there are. I'm going to use P to represent the number of people. And you define something with that. Then you write a math statement using your variables and the numbers that were given that makes sense given the context of the problem. So for example, let's say that we have this word problem. So it says one number is 6 less than 4 times another number. The sum of the numbers is 9. Find the 2 numbers. So if I go through and underline the stuff that I know that one number is 6 less than 4 times another number. That's one of the facts they gave me. Then I also know that the sum of the numbers is 9. And the thing I'm looking for is the 2 numbers. So I'm going to define those 2 numbers right now. And I'm just going to define them kind of like on the sentence. So I'm going to say, okay, this number is going to be X. And this other number that they're talking about here is going to be Y. And I'm going to say, okay, well, now that I've defined variables for the thing that I need, now I'm going to try to make math statements from the information that was given to me. So this statement right here is actually really easily translatable into math language, because we would say, okay, well, one number is, is means this stuff is that, which means they're equal to each other. So I would say one number is, and then I have 6 less than 4 times the other number, which I called Y. So I say, okay, well, I know 4 times Y is just going to be 4Y. And then I have 6 less than that. So with the less than thing, sometimes people have a hard time knowing like which way to write the subtraction. So a good way to think about this is to just forget about the variables and say like, what is 6 less than 10? It'd be 4, right? Or like 6 less than 100 would be 94. Or 6 less than 12 would be 8. And if you look at that, like 6 less than something is going to be that thing minus 6. Does that make sense? So the way you would write this is as 4Y minus 6, because it's 6 smaller than this thing. So you take that thing and subtract 6 from it. Because some, like a common mistake on this is like doing 6 minus 4Y. But that's not what it was describing. So that's how you would write that equation. Does anyone have any questions on that? Okay. Then the next thing, and maybe I'll actually erase this and put it a little closer so it doesn't look weird. So the next fact that I know is that the sum of these numbers is 9. So what does the word sum mean? Addition. Yep. So we're going to have the two things added together. Is, again, is means equals. That is 9. So the sum of the two numbers is 9. And now we have two equations. And based on these two equations, do you guys think it'd be easier to do substitution or elimination? Substitution probably, because the x is already by itself. So you could substitute this in for x. And so you would say, okay, well, when I do that, I get 4y minus 6 plus y equals 9. Now I only have y's in the equation. I can add them together. I get 5y minus 6 equals 9. And add 6 to both sides, I get 5y equals 15, which tells me y equals 3. And then once I have that number, I can choose whichever equation I think is easiest to figure out what x is. And I think the second one is, so I'm going to say x plus 3 equals 9, which means x equals 6. And so these are the two numbers that I was asked to find in this word problem. Do you guys have any questions on that? Okay. On the homework, there's one kind of like this where they talk about the difference of two numbers. So on that one, the word difference means like you subtract them, because like the difference between, I don't know, like 10 and 7 is 3. So like you could do 10 minus 7 is 3. Just pay attention on that one, which number you decide to be the larger one. Because like if you did 10 minus 7, that would be 3. But if you did 7 minus 10, that would be negative 3. And in the problem, like the second statement involves like a smaller versus a larger number. So just keep those straight if you end up with that problem. Okay, so any questions on this so far? Okay, so let's do another example. So I like Harry Potter. I can't remember if I spelled Ollivander right, but Ollivander is the guy who sells wands to all the Hogwarts students. So let's say that Ollivander he sells wands to new students for 15 galleons, and he sells wands to non-students for 20 galleons. If he sold 158 wands one year and his total wand revenue was 2,425 galleons, how many wands did he sell to students and how many wands did he sell to non-students? So now that I kind of understand the context of the problem, I'm going to go through and underline all the stuff that I know. So I know that new students can buy their wands for 15 galleons. I know non-students can buy them for 20 galleons. And I know that he sold 158 wands and his total wand revenue for selling those was 2,425 galleons. And then the question that I'm asked is how many wands did he sell to students and how many wands did he sell to non-students? So when I'm writing word problems, I like to use variables that help me remember what they're talking about. So you can use X and Y, but in this case, I might use S to represent the number of wands sold to students. Just abbreviate it. And then I might use N to represent the number of wands sold to non-students. And it really doesn't matter what letters you use, but I like to use ones that help me know what it means. And notice that it's really important the way you define it, because you want to define your variables exactly or as exactly what you're looking for. So since we're looking for how many wands he sold to students, I'm going to have S equal the number of wands that he sells to students. Like I wouldn't want to define S to be like the amount of money he makes from students, because that's not what I'm asked for. So be very specific about what the variables mean and don't just say, oh, it represents students, because you might not know, well, is that talking about how much money he made from students, or is that talking about how many wands he sold to students? Because those are different numbers. So now that I've got my variables defined, now I'm going to go through and try to write a math statement that represents this situation. And whenever you write a math equation, you need to make sure that all of your units are the same. So like in this problem, we have galleons and galleons and galleons, this number is actually measured in wands, and then this number is measured in galleons. And so you don't want to have an equation that mixes them, because it wouldn't make any sense to like say, oh, I have this many galleons plus this many wands equals this many galleons. It's like, well, how did you add galleons and wands together to get galleons? So all of your equations need to have the same unit. And since we have our variables in units of wands, because S is the number of wands that students buy, N is the number of wands that non-students buy, then I'm going to probably start off by writing an equation that has to do with wands. So I'm going to say, okay, well, the only other information I was given in units of wands is this 120 or 158 wands. And that's the total amount. Yep, exactly. So you do S plus N equals 158. That would be our wand equation. And then if I look at the other information I'm given, I know that new students get wands for 15 galleons, non-students get 20, and his total revenue was 2,425 galleons. So I'm going to start off with that total, because that's kind of like a good place to start with an equation. So I'm like, okay, this is the total amount of money he made, but how did he make that money? Well, he sold wands to students, and he also sold wands to non-students, and that's how he made that money. So the things we're going to add here is the money he got from students and the money he got from non-students. But we don't know how much money he earned from students, because we only know how much a single student would pay. But we have a variable that says this is the number of wands that are paid, that are bought. And so we would say, well, the amount of money he makes from students is going to be 15 times S. Because however many wands are purchased by students, you're going to multiply that by 15 to find out how much money he got from it. So everybody call out, how much money did he make from non-students? 20N. And then now I've got two equations. That's a system. You could solve it with whatever method you want. And in this case, I don't think it really matters, because it would be really easy to like maybe multiply by -15 to cancel out the S's with elimination. But it also wouldn't be too hard to subtract one of these over and then substitute. So in this case, you could really choose whichever method you like the most. I think I'm going to maybe not solve it, because I think you guys got that pretty well last class. If you guys want me to, I can come back to this once we switch to homework time. But basically, you would go through and solve this, figure out what S and N are, and that would be your answer to the question. But really, like, the hardest part of this lesson is learning how to take the word problem and turn it into equations. Once you've got the equations, then it's just like what we did yesterday. Is everybody good with that? Or is there anybody who wants me to solve these? Okay. All right, so let's do another example. So on this one, it says it takes Mark 20 minutes to swim upstream 1,000 feet, and it takes him 13 minutes to swim downstream 1,000 feet. What is Mark's swimming speed in still water, and what is the speed of the river? So if we read through this problem again, let's underline the things that we know. It takes him 20 minutes to swim upstream 1,000 feet, and 13 minutes to swim downstream 1,000 feet. And the things we want to know is his swimming speed in still water and the speed of the river. So I'm going to have S represent still water swimming speed. And I'm going to have R represent the speed of the river. And again, you can use whatever variables you want. I just like using ones that let me know what they mean. So now that I have my two variables, I'm going to look at the information I was given and my variables and see if maybe I can write an equation. But the main thing I want to make sure is that all of my units are the same. So if I look at my units, I have a speed unit, and then I have minutes and feet and minutes and feet. So we've got lots of different units going on here. And the things we're looking for are both measured in speed. And so I want to see if maybe I can convert these into speeds, because that, like, the thing I'm looking for is measured in speed. So is there a way that we could convert this fact that he took 20 minutes to swim upstream 1,000 feet? Could we change that into a speed somehow? And yeah, go ahead. How would we do it? Perfect. Yep. Because if we take 1,000 feet, whoops, that's 100. If we take 1,000 feet and divide by 20, that would tell me that he's going 50 feet per minute. Because if you divide the number of feet by the number of minutes, you'll figure out how many feet he goes every minute. And I'm going to write this as the upstream speed, just so I remember what this is. And I'm writing it in blue because this is technically something that was given to me. I just had to like put it in the form so that was measured as speed. And then what would the downstream speed be? Perfect. Yep. So if I do 1,000 divided by 13, I think that actually won't divide evenly. What is it approximately if you guys type it in? Yeah, just what does your calculator give you? Like a
76.9, blah, blah, blah.
Okay. All right. So we're not going to use this number because we want to get an exact number. So when we plug it in, we're going to use this fraction in our equation. But this, like, I just wanted to get kind of an estimate so we can see how this is reasonable. So if we look at this, this makes sense that his upstream speed is going to be a smaller number than his downstream speed. Because like, let's say the river is flowing this way. If he's swimming against the current, obviously he's going to be swimming slower than if he's swimming with the current because the river would be pushing him down the river when he's going downstream. But if he's swimming upstream, it's working against him, right? Does that part make sense? Like why these numbers are different? And so now we need to see if we can write an equation. So now we have all of the information in the same units. So we have these two pieces of information that were given to us, and we have these two things we're looking for. So we want to think about it and we're like, okay, well, his upstream speed is a combination of his swimming speed and the river speed. Because if he's swimming upstream, he's got his own swimming speed, which is S, but then the river is pushing him backwards. And so we would have S minus R equals 50 because his swimming speed minus the river's speed, because it's working against him, is 50. And then when it's going downstream, it's the opposite because he's swimming with his speed, but then the river is also pushing him down the river. And so that would be plus R, and that equals the 76 or whatever. But we're going to write it as 1,000 over 13. Does that make sense? Cool. And then on this one, I would probably definitely use elimination because it's like perfectly set up for elimination. And I think on your homework, I don't think it ends up being a fraction like this. I might have done like a typo or something. Maybe it's supposed to be 12 minutes or something. But usually like it will add together nicely. So you do like 50 plus whatever that number is and add those up. Any questions on that? Okay. So again, just remember your equations need to be in the same units. So like we had wands plus wands equals wands, galleons plus galleons equals galleons. And in this case, we had speed plus speed equals a speed, or speed minus a speed equals a different speed. So units need to be the same within a single equation. So this is the last example I'm going to do, and I'll let you guys work on your homework. So this one says Margaret is collecting nickels and dimes for an art project. So she asks all the cashiers to give her the change in nickels and dimes. One cashier gives her 18 coins totaling 125. So I'm just going to underline that because those were given to me. How many nickels and dimes did the cashier give her? So I'm looking for how many nickels and how many dimes. So I'm going to have N equal the number of nickels. And I'm going to have D equal the number of dimes. Now, do we have any international students in here who don't know what nickels and dimes are? Okay, so they're coins, and nickels are worth 5 cents and dimes are worth 10 cents. So just write that down. So one dime equals 10 cents and 1 nickel equals 5 cents. Okay. So, and that's like information they assume you know, but you don't if you didn't grow up here. So, I don't think there's any problems like that on your homework, but if so, just like Google what the coin amount is. Now that we have all this information, we want to write equations with the stuff we know and the things we're looking for. So on these two, what are our units on this? For like N and D, are they dollar units or are they coin units? Coin units, right? Because we're counting the number of nickels. Yes, they will factor into one of the equations. Yeah. But these two specifically, like the number of nickels, like let's say we find out the answer is 5. It's not $5, it's 5 coins. So the units for, so the units for our variables are coins. So I'm gonna start off by using my coin number, and I'm going to write it as N plus D equals 18. Because the number of nickels plus the number of dimes is going to equal 18 coins total. So again, my units are matching here. Coins plus coins equals a coin measurement. Is everybody good with that one? Okay, now the next one, so that uses this piece of information, and then this part goes to what you were saying. How would we use this fact that the money amount adds up to 125? Mm-hmm. 0.05 N actually, but yep. Yep. Yep, sorry, that's kind of tiny. Let me rewrite that. But yep, that's exactly right. Because to find out how much money the nickels are, you would do $0.05 dollars or 5 cents, in other words, times the number of nickels, and then find out the amount of money for the dimes. You would do 10 cents times the dimes. So those would be your two equations. I think on this one, it also doesn't really matter whether you do substitution or elimination. You could go either way. I would probably recommend though that you multiply this equation by 100 before you solve it, just because it would get rid of the decimals and make it easier. And essentially what it's doing when you do that, like you'd get 5N plus 10D equals 125. What that's basically doing is it's converting these units from dollars into cents, because it's saying like you do 5 cents times the number of nickels plus 10 cents times the number of dimes equals 125 cents. But that's usually easier to calculate than a bunch of decimals. So I would prefer this version of the equation to that one, but you could do either one. And yeah, you could do substitution or elimination to solve it. So that's all of the examples I wanted to go over. Does anyone want me to go back and solve any of these? So we wrote them all as the equations, but we didn't actually go through and find the variables. Are there any you'd like me to go back to? Okay, cool. You can open up your homework then and get started. And if you have any questions, let me know. The which one?
Like tickets and the total amount of
Uh-huh. Which question is it? Because it's probably 3. Okay. So it looks kind of like this one. Okay. I can do it with your numbers too, since you're the one asking the question.
So I have 575 tickets.
578.
5.
Oh, 5. Like that?
Yeah.
Okay.
And then they were sold for a game for a total of 7.
Exactly 700. Okay.
And then adult tickets are 50. And then
Okay. Awesome. All right. So if anyone wants to follow along with question 3, you're welcome to, or you can just work on your own. Okay, so on this one, we have 575 tickets are sold. The total money is 700. We know that adult tickets are, I'm just gonna write it right here so I don't have to rewrite it. That's 150, and then children's tickets are $1. And the question is, how many of each kind of ticket are sold? So I'm gonna have A equal the number of adult tickets, because we're looking for how many of each kind. And C equal the number of children's tickets. Okay, all right, so with those two variables, which one are you how are you thinking we could write an equation? Ultimately, we'll get two, but which equation do you think might be easiest to write?
Originally, I 1.5A.
Yep, that would totally work. Because essentially what you're doing there is you're making a money equation, right? Your total amount of money is 700. The amount of money you make from children's tickets will be $1 times the number of children. The amount of money you'll make from adults is 150 times the number of adults. Okay, great. So that took care of, like if you want to, you can even like kind of cross off the ones that you used. So we've used, oh, that's the same information. So we've used those three pieces of information. I mean, they might show up again, but like most likely they won't. So if we look at the unused information, what unused information do we still have? Tickets, perfect. So we have a total number of tickets, which is 575. And is there anything else in the problem that's measured in tickets? The what? Say that again.
So like it'd be A.
Yes. Mm-hmm. Yep, because like A and C themselves are measured in tickets. So you can just say, well, this many tickets plus this many tickets equals the total. Yeah, and the reason we had to multiply here is because you take the number of tickets multiplied by the dollar amount per ticket to find the dollar amount of how much money you made from the tickets. Yep, so that would be it. And then what method do you think would be easy to use to eliminate or substitute? Okay, yeah, I would agree on that because like we kind of have like two C's that are almost eliminated. Like if we just made one of them negative, it would work. So let's go ahead and make maybe the second one negative. So I'll just like multiply everything by a negative, and now I can add these together. Well, I kind of skipped a step. Are you okay with, like, I didn't actually write out that I was multiplying them, but it would change the signs essentially. So when I add these together, 1C plus a negative C will eliminate 150A minus A will be 50 cents times A. And that's going to equal 125, I think. Something like that. Is that what 700 minus? Okay. And then to get A by itself, I divide by 50 cents, which I think will give you 250. And so that would be the number of adults. And then find the number of children. I would probably use this equation and you just say like 250 plus what equals 575 and figure out what children are. By the way, on your test, there's one question that's a word problem and it's like that one, like that form. It's not like one of the speed ones because I feel like those ones are significantly harder. So it's more like that. Yeah, which one? 2. Okay. Does yours look like this, or do you have different numbers? Three times the smaller is how much? Like that? Okay. Awesome. So when we look at what we know the difference of two numbers is 8. 3 times the smaller is 10 more than the larger. And we want to find the two numbers. So what do you want to call the two numbers? Okay, awesome. So we have X and we have Y. And in the problem, it sounds like they distinguished between which one was smaller and one was bigger. So which one do you want to be the smaller one? Okay, awesome. So we'll say Y is the smaller one and X is the larger. Okay. And so let's start with the second statement. So we have 3 times the smaller is 10 more than the larger. How would you write that as an equation?
Plus 10 minus 3 times y.
Okay, sorry, say it again.
X plus 10 minus 3 times y.
Okay, so we have the larger one. So yes, X plus 10, that's the larger. And that is 3 times Y, like that. Is that what you said? So I would just like read the sentence and kind of translate it as I go. So like it says 3 times the smaller. Well, the smaller you define to be Y, so you do 3 times Y. Is, well, that means equals, like 3 times the smaller is 10 more than the larger. So that means these two things are equal to each other. 10 more than the larger. Well, 10 more than the larger is whatever the larger number is plus 10. And so that would be that sentence. And I think what you said actually was the same. You said X plus 10 equals 3Y, which is the same equation. It's just written.
Well, I kind of said X plus 10 minus 3y, but it's so stupid.
Oh, I mean, I guess you could subtract the 3Y and make it equal 0. But like, it's probably easier to leave it this way. But yeah, so that would be the equation for the second sentence. Now the first one, it says the difference of the two numbers is 8. So like the difference between say like 100 and 20 is 80. And the way you calculate it is 100 minus 20 equals 80. And so in this case, we're going to write a subtraction problem, but the question is, which one do you put first? Do you do X minus Y or do you do Y minus X? Yep, because X is the larger one. Because if you take a large number and subtract a smaller number, that's going to equal a positive 8. I mean, technically, I guess you could do Y minus X is negative 8. You know, take your little number and subtract a big number and get a negative difference. But it's probably easier to work with it if it's positive. And then once you've got it to there, do you want me to keep solving it, or do you want to try solving the? Okay, cool. If you want me to go back and solve that, I'm totally fine to do that as well. Yeah, which number is it? On question 8? Yeah? Okay. All right, so what are your numbers on this one? Okay. And is that it? Okay. All right. Nickels and dimes, okay. So we have Bob has 19 coins totaling that amount. If he only has dimes and nickels, how many of each coin does he have? So yeah, what? Mm-hmm. 155 or $1.55. Okay, so that's where your equation is off, because either you want to write them all as cents or all as dollars. So if you do 5 times n, you're basically counting pennies, and you're saying I have 5 times, like I have 5 cents plus 10 cents. But if you put a decimal in the 155, you're saying that like your total amount is 1.55 cents. And so, but if you leave it as 155, then you're basically like counting all of them as cents. Or you could also like, so this would probably be easier in terms of solving it, but you could also write it as dollars like this. That would also be just as valid. Either one of those would work, but you can't like mix the two. Yeah, so that should fix it. Yeah, which number? Okay. What are your numbers? Mm-hmm. Okay. And then what's your interest? Okay. And I'll replace 6 and it's 7. Okay. Awesome. 7,000. Okay, sorry, say that a little bit louder. 790, like that. Okay. All right, so what did you define your variables to be? Okay. You want to use I for, and what does it represent? Okay, yeah, so because we have 2 things we're looking for, right? We're looking at how much money did he invest at 6%, as well as how much money did he invest at 7%. So like we're gonna have 2 numbers. So let's see, how could we? Maybe let's do X for 6. So the amount he invested at 6%. And then well, because 6 and 7 both start with S's, because I was thinking I might use an S for one, but since they both start with S's, maybe we'll use the last letter. So X is for 6, and we could do N for 7 because it's the last letter. Whatever variable you want to do, it doesn't matter. I'm going to use N, so it reminds me that it's the amount at 7%, because 7 ends with an N, but you can choose whatever you want. So with this, we say, okay, those 2 are the amounts he invests at those percentages, right? Like that's the amount of money he invests. So in this problem, looking at units may not be super helpful because it all has to do with money. right? You have like the amount he invests in, is like the total is 12,000, and then you also have an interest money of 970, or sorry, 790. And so those numbers are both measured in dollars. So separating it by units may not be helpful, but the types of money are different. You've got investing money versus interest money. And so that's going to kind of be your distinction between your two equations. And so we'll say, okay, well, X and N are both investing money. It's the amount of money you invest. That's what we're looking for. So we can start off by saying, well, X plus N has to equal the 12,000. And then the interest part, we would say, okay, well, the total interest is 790, and the interest is being earned in two ways. The X amount is getting 6% interest, and the N amount is getting 7% interest. And so the way you calculate 6% of a number is you do 0.06 times whatever the number is. And so that's going to be 0.06 times X, and then 0.07 times N. And then probably in that case, you'd also want to multiply by 100 to get rid of the decimals and stuff, but that's the setup of what it would look like. Yeah, because it wasn't really distinguishable by money. So in situations like that, just look if there's like two types of money, like investing money versus interest money, and that can help clarify that.